Hi, this is Dr. Jivikas Paul. In this session, we'll discuss about unit load method or virtual work method or Castiglione's second method. It can be called in any way. For deflection, we need to apply unit load. So, suppose if we take a simply supported beam, okay, this beam. Suppose I need to find deflection at E. Okay, now what I need to do is I need to apply 1 kilonewton unit load at E like this. For deflection, we need to apply unit load. For slope, we have to apply unit moment. Suppose if I need to find slope at B, then I need to apply 1 kilonewton in this method. So, okay. Next, the formula for deflection and slope are, so deflection equal to 0 to integration 0 to L capital M m1 by EI dx. Slope integration 0 to L capital M m2 by EI dx, where capital M is a bending moment due to external load, m1 is a bending moment due to unit load applied at the point of deflection, m2 is a bending moment due to unit moment applied where the slope is required. We'll understand more clearly in the problem. So determine the deflection and rotation at the free end of the overhanging beam. Overhanging beam is given here, A, B, and here it is overhanging, shown in the figure. Assume uniform flexural rigidity, uniform EI value. Now we need to, at free end he is asking to find the slope and deflection. That means at C, we need to find YC and theta C. Due to this deflection, there will be some deflection. Due to these loads, there will be some deflection. We need to find that YC and theta C using unit load method. So in unit load method, for the first step is to find the reactions. Okay, these reactions RA, RB. Using sigma moment about A equal to 0 and sigma Fy equal to 0, we can find the reactions. Then we need to write table like this way, which consists of span, origin, limit, m1, m2. So we need to find the m equations here. So CB, BE, ED, DA. Okay, CB, BE, ED, and DA. Limits 0 to 1, 0 to 1, 0 to 0.5, 0 to 1.5, 0 to 1.5. These are the limits. And the origins C, B, E, and D. Now what is this m, m1, m2 values? See, here we need to take three diagrams. First one is M diagram, M1 diagram, and M2 diagram. Now what is M diagram? This is the diagram given in the question. This is the M1 diagram, is remove all the loads and apply unit load where the deflection is required. That is, at C you applied 1 kilonewton and remove all the loads. That is M1 diagram. And remove all the loads at C you apply 1 kilonewton meter. This is your M2 diagram. Yeah. So first for CB portion, that means for this CB portion, between this CB portion we need to take a section. So we have taken section XX at a distance of x from C. Now at this point I am calculating the moment. So this load into this distance. So 10 into x by 2, 10x square by 2. The right side clockwise, so from reverse, therefore minus. Yeah, next to B, between this I have taken section. So if I calculate here, it is 41 point, this is RB value, RB into x minus 10 into x plus 1 into x plus 1 by 2. If you simplify, you will get this one. Next ED, I am taking in between ED section, from D I am taking, so I am taking here. So 50 into x minus 50 into x plus 23.75 into x plus 1.75. And next if I take here between DA, I will get 23.75 into x. Like that we get m values. Next m1. So for this diagram, the same procedure. See, I am taking moment here, 1 into x. Next I need to take between these two, this into perpendicular distance, this into perpendicular distance. ED, this into perpendicular distance, this into perpendicular distance. Next, coming to this one, M2. So here, if we take here XX, what is the moment here? Only 1 kilonewton. So minus 1. Okay. So as there is no loads here, this effect will not be there on this. Okay. So remaining 0, 0, 0, 0. So next step, calculation of deflection at C. So delta equal to integration, that YC equal to integration 0 to L m m1 by EA. So for each span we need to consider this this for CB, BE, ED and DA. Now substitute all the values here. For each portion we know M value and M1 from this table. Okay, so substituting all the values and simplifying and applying integration and again simplifying, we will get YC as minus 22.89 by EA. Theta C equal to 0 to L M M2 by EA dx. So here a capital M for which portion? This is for CB only we have, that is minus 1. So this into this one, remaining everything is 0. Okay, so M into M2, MM2, so this one, so we will get 5 by 3A theta C. Okay, next for truss, find vertical deflection at joint G, joint E for a pin jointed truss. This is a pin jointed truss. There is a load, horizontal force and vertical force here, support, roller support and hinge support. Due to these forces, what happens is the forces will be generated inside the members and the E will be having some deflection, E joint. So we need to find the vertical deflection at joint E. Okay, using which method? Unit load method. Take EA as constant in all members. Okay, this YE we need to find. The formula here for truss, it is YE deflection equal to sigma PKL by EI. Now what is this PK, we'll see. Okay, now first we need to find the reactions, then we need to do P analysis, then K analysis, then sigma PKL, then sigma PKL by EA gives your deflection. So how to find the reactions are VA and VB. Here you have VA, HA, VA, HA. Here VB. Applying sigma moment about A equal to 0, sigma Fi equal to 0 and sigma Fx equal to 0, we can find VB value and VA value and HA value. Okay, yeah. Now P analysis. Now draw the figure as it is given in the question. Right. Now the theta is equal to tan inverse 3 by 4. So theta is 36.86. Now joint by joint we need to calculate the forces. Now first I am going to joint A. So here the free body diagram is this one. This is the free body diagram. Now apply sigma Fy equal to 0 and sigma Fx equal to 0. So here we have taken outside. Okay, we got minus here, therefore compression. So sign conventions, compression means we need to show in this way, tension means we need to show here in this way, inside. Okay, now after applying sigma Fx equal to 0, I got F plus 24, this for tension. So minus 15 I am showing here in this way, and here in AF tension is in this way towards. Okay, and joint C, next I am going to joint C. So joint C free body diagram. So joint by joint we need to go and we need to apply sigma Fy equal to 0, sigma Fx equal to 0. In that way we can calculate all the forces in the members. Okay, next K analysis. What is this K analysis? Okay, remove all the external forces. This force is removed which is at C, and this force is removed which is at F. And I have applied 1 kilonewton at E because we need deflection at E. So I have applied 1 kilonewton at E. So now calculate all the member forces in the members. Okay, first of all I am calculating the reactions here by applying sigma Fy equal to 0, sigma moment about A equal to 0. Then joint by joint I am going and I am calculating, I am applying sigma Fy equal to 0, sigma Fx equal to 0, and I am calculating the forces in members. If it is minus, compression, plus tension, so I am showing in this way. So in that way we can calculate forces in all the members, joint by joint, joint by joint, joint by joint. Then all the members you write in this column, all the P values, the forces which we got in the P analysis. These are the forces which we got in the K analysis. Lengths you write here, diagonal members you apply Pythagoras theorem. Okay, now P into K into L, this is the value. Now sigma PKL, now deflection equal to sigma PKL by EI. So 261.64 divided by EI. Thank you.